Hello, this is OCR Further Statistics. We're in Probability 1, Arrangements and Counting, and the third video on repetitions and restrictions. There are several points where it's a good idea to stop and work some things out for yourself. Whenever you see this symbol, pause the video and try to answer the question before continuing to watch. OK, it's my set of volumes of statistics again. Now I have some duplicates. How many distinct ways are there of arranging this set of books? Pause the video while you think about the question. OK, well, I've got 8 books in total, so that's 8 factorial ways of arranging them. But I've got 3 identical green ones. So that will give me 3 factorial times too many ways of arranging them. And I've also got 2 orange ones, so that will give me 2 factorial times too many. So I need to divide my 8 factorial by both 3 factorial and by 2 factorial. Let's start to generalise again. I've got N books, and I've got R copies of Volume 1, S copies of Volume 2, and T copies of Volume 3. How many ways can I arrange them? This isn't a full generalisation, it's just beginning to make some inroads into it. Pause the video while you have a think about it. OK. Well, I've got N books, so that's N factorial arrangements in total. But some of them look the same. I've got R copies of Volume 1, so that's R factorial times too many arrangements. And I've got S copies of Volume 2, so that's S factorial times too many arrangements. And I've got T copies of Volume 3, so that's T factorial times too many arrangements. So N factorial divided by R factorial, S factorial, T factorial. In general, what we're doing is uncounting the repeats. So generalising in full, if I've got N objects, there are N factorial arrangements, but if RA are the same, I need to divide by RA factorial, RB are the same, divide by RB factorial, and so on. Giving a general formula here. You may want to pause the video and make some notes. OK. Here, all my books are different, but I've got some restrictions on how they can be arranged. I want to keep all the volumes of statistics together and both volumes of mechanics together. Pause the video while you have a think about this problem. OK, what I'm going to do is pretend to stick the books together so that they are a single object. This diagram shows what I mean. So my 3 volumes of statistics are now a single object, and my 2 volumes of mechanics are now a single object. Now I've got 5 distinct objects, so 5 factorial ways to arrange them. But that's not going to give me all the possibilities. Why not? Pause the video again while you have a think about what we haven't done. OK. We said the books had to be together, but not necessarily in order. So while I've got S1, S2, S3 here, it could be S1, S3, S2. Or S2, S1, S3, and so on. So that gives me 3 factorial arrangements for each of these 5 factorial that I haven't counted. And similarly, there are 2 factorial, in fact just 2 ways, of arranging my 2 mechanics books for each of the arrangements I've got so far. So I need to multiply by 2 factorial. That gives me 5 factorial times 3 factorial times 2 factorial. There isn't a general algebraic rule here. There are just too many variants. But what you have now is a method for making use of the counting strategies that you have developed. What about separation? I can't stand red, orange or pink together, so I need to keep the statistics, mechanics and calculus books separate. As usual, pause the video while you have a think about this question. OK, this needs quite a different strategy. What I'm going to do is to start with the books that don't matter. So that's pure, discrete, further pure, logic and GCSE. So that's 5 books, that's 5 factorial ways of arranging them. Now I've got to put the other books in so they're not next to each other, so I can put them in any of the gaps, but I can only put one book in each gap, or I could put them at the ends. So I have 6 gaps and I've got 3 books, so I need to choose 3 different gaps to put those 3 books in. Remember, I can't put them in the same gap because I've got to keep them separate. So choose 3 gaps out of 6, that's 6, choose 3 ways, which is 20. But of course I've got these 3 books, statistics, mechanics and calculus, and I can put those into my 3 chosen gaps in any order. So there are 3 factorial ways of arranging those 3 books in the 3 gaps that I've chosen. So putting all of this together, I arrange the remaining 5 books, that's 5 factorial. I choose 3 gaps out of 6, that's 20. And I permute the separated books, that's 3 factorial. These are 3 different things. I'm doing one and the next, so I use the AND rule. That gives me a total of 5 factorial times 20 times 3 factorial ways. 14,400 ways of arranging my books. That's going to keep me busy for a very long time. That's the end of this video on repetitions and restrictions. The next and final video in this section looks at applying these ideas to probabilities.